And I will allow Damien O'Sullivan to introduce today's webinar topic for us. Damien's an Extension Officer with the Department of Agriculture, Fisheries and Forestry in Macrae. Over to you, Damien.
Good afternoon all. This webinar is an initiative of the Department of Agriculture, Forestry and Fisheries as part of the Department's response to the escalating drought situation that we've got across a significant area of the state and no doubt in other areas of Australia at the current time. So thanks to the Bureau of Meteorology and Department of Science, Information, Technology, Innovation and Arts for presenting today. The information is designed to help producers with their risk management strategies as we move into this really quite crucial period in the spring-summer season. We intend to hold further seminars on the weather, and John's going to conduct a short survey later on to determine what your priorities might be in this sort of area. There's also a possibility of conducting a webinar on Queensland Government's drought assistance scheme if there's sufficient interest from people today. So good luck with the weather, and I'll hand back to John.
So the first session today is looking at the next generation forecast and warning system. And to help us better understand what it offers, we have Vikash Prasad, a meteorologist with the Bureau of Meteorology in Brisbane. Over to you, Vikash.
Thanks, John. Good afternoon, everyone. My name is Vikash, and I'm a forecaster at the Forecasting Centre here in Brisbane. And I've been doing the coordinating of the next-gen implementation of the next-gen forecast warning system in Queensland for the past year. A little bit of my background: I'm originally from Fiji. I worked there for about 7 years, and I've also worked in Darwin for about 5 years before moving to Brisbane. I've been here about 8 years. So basically, I've seen through most of the tropical regions of the weather systems that affect the southern hemisphere and mostly in northern Australia. A fair bit of background into tropical cyclone forecasting and monsoon flows as well. So getting on to the discussion for today, basically we've seen quite a big change in Queensland, the implementation of the next generation forecast warning system. Other states have already had this system before. We'll talk a little bit about that. Moving on, next slide shows that this has been a 5-year implementation project. It started off in Victoria in 2008 as a pilot program. Initially the system was bought from US, but has been modified for Australian use. And over the last few years it has been rolling through the other states, and eventually we've had the implementation go live here in Queensland on 2nd October this year. Northern Territory is the only territory that's left that will go live next year, and that will complete the next generation forecast and warning system project. So what is really the next generation forecast warning system? Suppose to understand this, we'll just have a quick look at how things were done before NextGen was implemented. So basically on the left of the screen, we can see that there is this forecaster here with a big question mark. Basically the forecaster looks at the charts, the satellite images, radar observations, and also computer model data. Basically the computer model data is forecast for the next 7 days, and we have the Australian model, which is the Access model, the US, European model, UK model. We also use Japanese and Canadian models. So quite a lot of information the forecaster has to analyze before the forecaster is able to make up his or her mind to put in a forecast. So basically it's all pictures, then it's converted into text by the forecaster, and then the forecaster sends that product out, which goes onto the web, and it's read out on the radio or on television. So that's how we used to do the forecasting before NextGen was implemented. Now, since NextGen has been implemented, we see that the left side, the input that goes into the process, hasn't changed. So if I flick to the next screen, I'll just flick back one more time to see how the left side of the screen doesn't change. So basically the process that was there before is still in place, but I suppose the input that goes into the system is still in place, but the process has changed. So instead of forecaster typing the text, the forecaster now edits what we call the grids. The grids are 6-kilometer spatial locations across the country, or basically we talk about Queensland in this case. And the system that's used is known as GFE, or in other words, it's It's abbreviation for Graphical Forecast Editor. Basically, it has a 6-kilometer grid, and at each grid point, there is the parameter that is required for a forecast, such as temperature, relative humidity, wind speed, direction, cloud, weather components, whether it's rain, showers, or thunderstorms. So at each point, then we're able to produce forecasts in form of graphics, or the computer system is smart enough to be able to produce the text automatically for us. So instead of forecaster typing forecast for hundreds of locations across the country and spending so much time to doing that, the system is able to generate that on its own. And with that, we're able to produce text, graphics. This image here is a image of the fire danger ratings for Victoria. So instead of just getting a point location fire danger rating, we see a spatial distribution of how that ratings is across the state. Also, this image here is graphics, which is on where the users are able to see the information, and this is in this system is known as Macrae. We'll have a little bit of a discussion about that. Of course, the Macrae has been live in other states like New South Wales, Victoria, South Australia, and Western Australia. Northern Territory and Queensland, again, the only two states and territory that haven't had this system yet. So we'll have a look at what has changed in terms of products. So we'll go to the next slide. You can see that the Queensland web page has now changed. It used to have information in a different format. The whole format has changed. It's very much in line with other states. So basically, if you move from one state to the other, you'll find that the web pages are pretty much the same. The additions to the pages are a clickable map for the district forecast, which we already had before, but the new addition is the 7-day town forecast map. There's also this pamphlet that we had at the time of the implementation. It suggests that we've gone from 4 locations having 7-day forecast. Those 4 locations were Brisbane, Ipswich, Gold Coast, Sunshine Coast, to 67 locations across the state. And this has only been possible because of NextGen. So if we click on this link here, it takes us to this map. Now this map basically shows all those locations that have the 7-day forecast now. The locations have been chosen based on a large number of reasons or conditions, I suppose. Starting off with population, geographical location, climatology, whether there's any major industries around it. Now this is only a starting point because we needed the forecasters to get used to the system. So we didn't want to go with a large number of locations. So there's quite a few more locations that we have had requests for, and we will be looking at putting those new locations in the coming months as the system matures and the forecasters get more comfortable with it. So if we click on one of those locations, say for example in this case we click on Charleville, then we get this pop-up which gives us the 7-day Pricey forecast. Pricey forecast is just a short form of the forecast. Basically we have for the 7 days the weather icons, and then we have the short a few words to explain what the weather would be like, and of course the maximum and minimum temperature. To get a detailed forecast, there's a link here called Detailed Charleville Forecast. So if you click on that link, then we get this sort of forecast. We have the prices on the left here, but we also have the worded forecast on the right. And plus, there's this new edition where more 7-day forecasts can be found around for that district. So this is another addition, changes to the forecast that we have seen. And moving on from the town forecast to district forecast, the district boundaries haven't changed in this case for Queensland, whereas we've seen that in WA or New South Wales, the district boundaries had changed. And there were some reasons behind why those boundaries needed changing. But we realized that for Queensland, we've had these district boundaries for a while, and people are used to this, they know where they are. So these district boundaries have remained the same. However, the forecast in the districts have changed as well. So we have added more information on it. So we're looking at starting off with information about cloud, weather. Wind speed is now in kilometers per hour, but also given in ranges. So we're looking at the lower end, the upper end, the wind speeds, also the temperatures in the maximum and minimum temperatures. Some people may have noticed that the district maximum minimum temperature ranges does not account for sometimes, say for example, the Darling Downs where Toowoomba or Warwick temperature may be outside the range. This is because the temperature range only takes into account the 10th percentile and 90th percentile, so it does exclude the extremes. So in some situations there would be some locations that would be outside the range, but overall it's more or less the average temperature that you'd see in the district forecast. And of course we have the fire danger ratings and the UV alert. That's only for day 1. So let's have an example of the forecast that was issued for Darling Downs this morning. As you can see, there's quite a bit of information in the weather situation, plus in terms of the wind speed and the direction as it changes, and the temperatures that's going to be experienced during the day, both the minimum and the maximum. Now moving on from just the text-based forecast, we are moving towards more graphical forecast. And as explained before, this new feature, or before we jump onto that, we'll just have a quick look at if this page here, if people are interested in getting more information regarding NextGen. All we have to do is type NextGen FWS in here and click the search button, and we'll find this is one of the links that we had generated before we went live around 2nd October. Now it gives information regarding the state forecast, district forecast. There is what we call metro forecast. So for Queensland we have Brisbane, Sunshine Coast and Gold Coast, which is more like a district forecast but a smaller area. And then the town forecast and Précis forecast. More information can be found on this also in the brochures that's located on the right side of the screen. So there's sample district brochures and town and other forecast products. Also, you may be interested in looking at the additional information that's there, the FAQ, and some changes that we have made to the products also available on that page. So that's quite an informative page to look at in regards to what changes have been brought about by NextGen forecast and warning system. Now, as I said before, we were going to look at METI. So this is the home page of the Bureau of Meteorology, and in here is the link to METI. The METI is the access to the gridded data. Now, we're looking at data available at every 6 kilometers across the state. That's a lot of information, whereas we're only providing 7-day forecasts for only selected locations. The main reason for that is, at the moment, the system is still quite new, so we want forecasters to get used to it. Other states like New South Wales, Victoria, and South Australia, they have METI already. So let's have a look at what METI shows. This is some of the snapshots from the METI page. Now it gives us current observations. On the left, you can see temperatures. This is all. It can also be given in like spatial indication, so people can get a sort of view of where the temperature changes. Relative humidity, rainfall since 9 a.m. and rainfall in the last 10 minutes, wind speed, sea surface conditions. So there's quite a lot of information available in terms of the observation. But also the forecasts are located below the observations. So say, for example, if you clicked on rainfall or temperatures or wind, we get panels like this. So this is on the left is a spatial wind forecast, and on the right is the temperature. Now, in this case, we've got information over Queensland, as you can see, but if you go to the website now, you wouldn't get information on Queensland because this is only in testing mode, and we're only able to see that within the Bureau. But this is just to show an example of how it might look, and we can see the winds coming in from the southeast, turning inland ahead of this trough, which is approaching from the west. So that gives an indication of how the wind speed, which is given on the right, increases as this front from the west. You can also move through the time range. So this is like at 00 in the morning, and then move through at 11 a.m. and then in the afternoon, and also on for the next 7 days. And similarly, you can see the spatial distribution of the temperature as well. Plus, apart from the spatial distribution or the graphical forecast, we also have the 7-day forecast, which is fairly similar to the pop-up we have at the moment on the static image. Now again, this is only available in other states at the moment, so if one clicked on a balloon here, you would get this 7-day Précis forecast. And notice that it's got this chance of rain and rainfall range here as well. Now this is something that we are looking at introducing in Queensland as well. That's more likely when METI goes live. Now the chance of rain is the the percentage of chance of rain getting more than 0.2 millimeters in a particular day. So this is a daily rainfall. And then the rainfall range is generally the 50th and the 25th percentile. So we're looking at sort of a typical rainfall range. It doesn't account for the extreme or high rainfall range that we can get in tropical weather situations. So to get more detail on this, we'd click on the text views, which is up on the top right-hand corner, and that gives us a breakdown of not only for the day, but for 3 hourly sections of the day. So here is the chance of rain in 3 hourly intervals. And this is a forecast for Sydney, so it's basically this was over 2 days ago, yesterday actually, so on Tuesday, and the expected rainfall as well. Now, this is only for the day, but if you clicked on detailed 3 hourly forecast, we get all this information, and this is like not only for that day, but for the next 7 days. So you can see the power of having this gridded information available. Now, this gridded information is very similar to the access model data that people may have been using or seeing on our, like the interactive weather maps. Now, the difference between that is that this information has been manipulated by the forecaster. So the model data is the starting point for the forecasters. Now, the forecaster may choose to start with computer models forecast by Australian model, or may choose that European model or the US model is doing better today in this situation. Let's start off with that. Or may even choose to do a blend of the models. And the forecaster will pay attention to those particular areas that need more detail in, say, for example, orographic lifting or heavy rainfall near the coastal areas or tropical systems. So in other words, we have additional information put in by the forecaster, which we call value added to the forecast, the model forecast. And this information is now going to be available for 7 days at every 3 hours and across Queensland. So basically, we're looking at every 6-kilometer grid, and clicking anywhere within that will result in that forecast. And I'll probably just leave it there. Then that's what we're looking at coming ahead in the next year. But for now, we do have 70 location forecasts that have been introduced across Queensland with next generation system.
Lovely. Well, thank you for your presentation there, Vikash. Now, to help us better understand what might happen later this year, so the climate outlook for summer, we now have Dave McRae, who's a climatologist with the Queensland Government. He is, of course, well known for his weekly column in the Queensland Country Life. So great that you can join us today, Dave. I can see your screen there, so if you can just pop it into full screen mode. Excellent. That's good. So over to you now, Dave.
Thank you, John. Hello, everybody. What I just thought we'd cover today is the seasonal climate risk. It has got a Queensland focus. I apologise to those from other states, but hopefully there will be enough information in there for you to get something out of it. What I'm just going to cover today is...
Just notice you're a little bit echoey there. If you're using the hands-free, could you pick up the phone, please?
Is that better?
Oh, yes. 100% better. Thank you very much.
Not a problem. For today's topics, so we cover the current context, especially for rainfall for Queensland and temperatures. Have a look at our key drivers such as sea surface temperatures in the Pacific Ocean and the current state of ENSO, that's El Nino, Southern Oscillation. Have a look at the seasonal outlooks. We'll look at three different ones today. It'll be the SOI phase outlook, the Bureau of Meteorology's POAMA, both temperature and rainfall outlook, and the Queensland Government Spotter 1 forecast. And I'll finish off with just covering some available tools and links for more information for people to go and have a look at themselves. The current context. More than 60% of Queensland's drought declared under state government processes currently. The image there is as of the 1st of October 2013. It potentially would be reasonable to expect that area to expand depending on the timing of spring and summer rainfall and how that develops. There's a couple of links there for those who are adversely affected. The first link takes you through the Queensland DAF webpage, and you can find out what assistance in terms of both social and also fodder and water subsidies, etc. Like that. For more of the drought situation updates, if you go to the Long Paddock website and just click on the drought tab, that will take you in there. But yeah, certainly a large proportion of the state is currently impacted by below average rainfall. If we have a look at what else has occurred over the last 12 months, certainly a contributing factor in my opinion has been the above average temperatures experienced not only throughout Queensland but basically across most of eastern Australia over the last 6 to 12 months. If we just have a look at September 2013, it was the warmest on record, and the graph that you're looking at there just shows maximum temperature anomalies for the month of September from 1910 through to 2013. If the bar is red, it's showing above average temperatures for that month. If it's blue, it's showing below average temperatures for that month. And certainly if we go through to 2013 and you have a look at it, it was around 4 degrees warmer than the long-term average. And that follows on from a number of other, well, that certainly reflects the persistent above average temperatures that have been experienced for some time now. We take into context, September was the warmest on record. If we have a look back at the last 12 months, that's the warmest on record of any 12 months across Australia as a whole, regardless of the starting month. If we have a look at January to September, warmest on record for Queensland. January was the second warmest, June was the third warmest, August was the second warmest. So below average rainfall, above average temperatures, certainly increased evapotranspiration, plant stress, etc. like that. So if we go through now to the current sea surface temperature anomalies, if we're looking at the image here in front of us, there's Australia down the left-hand side, South America, that centred dotted line there that I'm moving my mouse along is the equator. The key region of the Pacific that we look at in terms of ENSO is basically within the black box there. That has changes in sea surface temperatures in that region there, drive changes in background climate for about 2/3 of the world. If ocean temperatures in that region there are shown as red, as in warmer than average, we talk about an El Nino climate pattern. If they're shown as blue, as in cooler than average, we talk about a La Nina climate pattern. And as we can see at the minute, there's no clear distinct pattern there, so we talk about a neutral ENSO pattern. A couple other things that are worth looking at currently for Australia is the amount of warmer than normal sea surface temperatures around Australia. Yeah, there is quite a significant area of warmer than normal ocean temperatures off the east coast of the Australian continent. That certainly helps keep temperatures above average. For Queensland, to encourage monsoon trough development, to encourage the inflow of moisture across the continent, I'd certainly like to see ocean temperatures, if my mouse comes back, off the Queensland coastline become warmer than average. So ENSO is in a neutral pattern, and if we have a look at the SOI, Southern Oscillation Index, is the difference in barometric air pressure between Darwin and Tahiti. We measure it on a daily basis, although from a forecasting or having a look to see what the risk of well above or well below average rainfall is, generally speaking, if it's a positive SOI, as in consistently positive over a number of months, say above +6, we would expect increased opportunity for rainfall. If it's consistently negative, as in remaining, say, below -5, -6 for a number of months, we expect less opportunity for rainfall. And if we have a look back over the last basically year and a half, generally speaking, the SOI has certainly remained within the neutral type pattern, occasionally dropping down into strongly negative. We talk about currently, I think the 30-day average of the SOI currently is about +1 in that region there, so still well within that neutral type pattern. We can use, and I should also have mentioned with this sea surface temperature one up here, is while it is in a neutral type pattern, at this stage, there's no risk of an El Nino developing, which is a positive news. On the other hand, there's no risk of a La Nina developing. The key time that I would be watching for some significant changes in this sea surface temperature map here would be late summer, early autumn next year. The models that the Bureau use to forecast changes in this region here show this neutral pattern persisting through to January at least. And so realistically, I wouldn't expect any significant change in SOI values either until then. So if we use the SOI phase in historical rainfall data, we can develop a seasonal outlook. The map of Queensland you are seeing on the right-hand side shows the probability of exceeding or getting above median rainfall for the full 3 months of October, November, December, based on a near zero SOI phase at the end of September. Generally speaking, there's a 40 to 50% chance, or slightly below, but near average, of getting median rainfall during October to December throughout Queensland. One way of thinking of that is it's an average outlook. A couple points to take into account, especially for the further west and further north regions, is that yes, we have left our traditional drier season of July, August, September, but realistically, if we look at green days in terms of pasture growth, etc., for most of the western and northern Queensland regions, we don't expect a proper green day until we get into late December. So while this talks about an average outlook for the coming 3 months, I'd be more comfortable the later we get into that 3-month period rather than the earlier we are. In terms of if you want to keep updated with that information, the Long Paddock website there, the link there, will take you through to that information. If we have a look across Australia as a whole, interestingly, it's a fairly neutral outlook across Australia as a whole for the coming 3-month period. Rainfall probabilities are slightly, and I use the term slightly, improved for southern New South Wales, parts of Victoria, southwest WA. But generally, across Australia as a whole, not significantly different. Oops, sorry. Again, if you want to get updated information on that, there's a link through from there. So you can look at that visual type of information, or you can downscale it to your site-specific location. Now, what I've got here is just the chance of rainfall at Roma, Central Queensland. It's based on the historical rainfall data. There's rainfall records at Roma from 1878 through to 2013. What I've done here is we're looking at the rainfall period November to January. I've highlighted the phase we're in here. So these figures here are probabilities of getting this rainfall over here. So you could say, keep on going here, so we're saying our median rainfall for these 3 months is 195 millimetres. So 50% of the time you get above that, 50% of the time you get below that. Currently we've got close to a 50% chance of getting median rainfall. Not as optimistic or hopeful as if the SOI was in a consistently positive phase, then we'd have close to a 65% chance of getting above median rainfall, but certainly better than if the SOI was consistently negative, where it's close to a 20% chance of getting above that. And with the people who regularly use this type of information and that I communicate with on a regular basis, we use a 70% rule as a good rule of thumb, as a realistic figure to expect. So looking at this table here, there's a 65% chance of getting 160 mil, 80% chance of getting 120 mil. You could roughly say there's be around a 70% chance of getting 140 mil. So for Roma, for the November to January period, you could say a realistic rainfall figure would be 140 mil. And this type of information now that comes from the Rainman Streamflow product, which is a Queensland Government package developed certainly over the last decade or so. We used to sell the package, but it is now freely available for download. If you go to the Queensland Government's DAF website, go to the search engine or go to the search bar up on the top right-hand side, type in Rainman, it will take you to their webpage and you can download the package for free. Moving on, so in terms of the SOI phase outlook, as I mentioned, not as optimistic as many would hope, but certainly, looking at close to an average for the seasonal outlook. If we have a look then at the Bureau of Meteorology's POAMA temperature outlook, and we're first of all going to look at the minimum temperature outlook, basically above average chance of getting above median minimum temperatures for November to January. The way to interpret that would be that minimum temperatures are likely to be warmer than normal. And if we have a look down there, there's a link down the mouse back, there's a link there if you want to keep up to date on this type of information. If we go to the maximum temperatures, this is the maximum temperature outlook. Again, if we look across Eastern Australia as a whole, increased risk of above average maximum temperatures. So daytime temperatures likely to be warmer than average. And certainly if you look in the northwest and western parts of Queensland, you're talking 75 to in excess of 80% risk that daytime temperatures are going to be warmer than average over that 3-month period. So, you can interpret that certainly as hotter conditions expected. If we have a look now at the Bureau's POAMA Rainfall Outlook for the November to January period, and this outlook has certainly got some attention since they released it yesterday, and I've noticed some comments on the web and in the media about it. But if we have a look, the Bureau is talking lower chance of getting above median rainfall for the November to January period. And for parts of central and northwest Queensland, less than a 35% chance of getting above median rainfall. And I should have also pointed out earlier when I was talking about probabilities, we talk about a 30% chance of something occurring, there's a 70% chance that it won't occur. So in this case, for this region through here, you could say there's close to a 30% chance of getting above median rainfall. So 3 times out of 10 you would expect to get above median rainfall. However, 7 times out of 10 you'd expect to get below median rainfall. So looking at the POAMA seasonal outlook information, certainly looks like there's an increased risk of above average temperatures, certainly, and somewhat of an increased risk of below average rainfall for that period. The Queensland Government, because summer rainfall is so important to the Queensland beef, sheep, livestock, grains industry, etc. like that, Queensland Government has spent some time and effort developing what we call a summer rainfall outlook. So specifically the period we're defining here is from November through to the following March, so that 5 months. We've developed, it's called a Spotter 1 Index. It's available at the Long Paddock website. We email out a monthly update on this. The Queensland image here on the left-hand side is the current Spotter 1 outlook as of the 8th of October. For Western regions, the outlook is quite reasonable over that 5-month period. You're looking at at least a 60% chance of getting above median rainfall for that 5-month period. Keeping in mind that doesn't mean the 1st of November it's going to start raining. A lot of this rain could fall in the second half of summer. If we have a look at the major grazing regions of Queensland, so this is that key region through here, shown as the grey shading here. We then did an analysis just to split up and have a look at the probability of wet, dry or average summer. The top bar graph there just shows the percentage chance in all years, so what's happened historically. And if we pull out those analogue years where sea surface temperature patterns were similar to what they are now, this is what's occurred historically. 23% of the time it was wet, as in above median, for that region through there. 66% of the time it was close to average, but there was for average rainfall for that region there, but there's still a 10% chance of getting well below average rainfall throughout that region there over that 5-month period. There's plenty more reading and more information on the Spotter 1 forecast. If you go to the Long Paddock website, you click on the Spotter 1 tab, that will take you through there. They do ask for your email address so then they can just email out that information. Well worth a look. So we've looked there now at the 3 months SOI rainfall, temperature and the 5-month rainfall seasonal outlook. Just having a look at the Madden-Julian Oscillation, or MJO. A lot of producers like to use this as a shorter-term tactical tool. For those who aren't familiar with it, the Madden-Julian Oscillation, or MJO, is a band of low air pressure. Starts off the east coast of the Central African continent and travels around the globe, usually taking between 30 to 65 days. We used to call it a 40-day wave. However, as the timing of it can vary, we went back to referring it to as the MJO, and that allows for that. The Bureau of Meteorology has really upgraded its information on the MJO over the last couple of years. If you go to the link there, it will take you through to a really good site now. And also, while you're there, click on what's called the Weekly Tropical Climate Note. The Bureau staff in Darwin provide some good background information on where the MJO is, its likely impact on Australia and other regions as well. If we have a look on the right-hand side, we look at the spiderweb graph. Can be a little bit difficult to interpret, but the way to think of it is here. If you look down the bottom here, it'll give you some explanation. Labelled dots for each day. So if you see the numbers there, that's the date. The blue line is for October. The green line is for September. So you can see where it's gone. If it's in the circle there, we say that the MJO pulsar band doesn't stand out from background influences, can be difficult to discern where exactly it is. However, you can track it around the globe. If we start here where we say it normally starts, off the African coastline. So phase 1 is the east coast of Africa. Phase 2 and 3 is the Indian Ocean. Phase 4 and 5 is the Maritime Continent or the Australasian region. Phase 6 and 7 is when the MJO moves back out over the Pacific Ocean. Phase 8 is when it starts to cross the African continent again. For us, especially for the northern half of Australia, we're coming into the time of year where the MJO does have a strong influence on our climate and weather, especially through things such as the establishment of the monsoon trough, potential increased risk of cyclone activity, increased inflow of moisture across the continent, help with the development of storms, etc. like that. So the phases for tropical the northern half of Australia, the eastern half of Australia at this time of year that are worth watching for is as the MJO crosses the Indian Ocean, so certainly the second half of phase 3, well into phase 4, 5 and then 6. So that's what region there at this time of the year when it starts to have a positive influence on our expected rainfall. As it goes through this region here, it actually can suppress our rainfall and enhanced dryness. So looking forward through to, say, based on where it's currently in, I wouldn't expect the MJO until mid-November would be the earliest I would see it crossing Australian longitudes. But this website is updated on a daily basis. You can easily follow it, and the weekly tropical note is updated every Tuesday, so well worth a read just to keep a track on that. So in summary, current seasonal conditions reflect last summer's very poor wet season, followed by above average temperatures or well above average temperatures in many areas. El Nino neutral conditions are likely to persist at least through until January, February, and I'd expect them to persist right through until autumn. The Decidia, as in the Queensland Government spring and summer wet season outlook, somewhat near average, although as I would point out there is a risk of below average rainfall for this coming spring and summer. The Bureau of Meteorology outlook, especially their latest outlook, is certainly drier than earlier forecasts, so it'll be worth watching to see what happens with that risk. And there is a high probability, in some areas I'd say there's very high probability of hotter than normal temperatures, both as in day and night time, and that could certainly have some impact in terms of animal welfare, water availability, etc. like that. Sources information. There's plenty of links to go through to get good quality climate risk information. There's 4 of them there. That's the Queensland Government one. That's the Bureau of Meteorology one. Their ENSO wrap-up that's updated twice a year is well worth a read. Provides plenty of background information. The CPC one is the United States one. Worth a look if you're interested in things such as grain price fluctuations and things like that. IRI, International Research Institute, also provides a good one. There's also things such as UK Met Office, the European Centre for Weather and Met Forecasting also provide quite an interesting seasonal climate outlook. I mean, from my perspective, if producers spent 30 minutes to an hour once a month having a look at a few of those websites, they'd get a good gut feel as to what's likely to occur in terms of their seasonal climate outlook. I recommend that people have a look at a variety of them and develop a bit of a consensus view. I mean, often they start to show similar type of things. So you can get a bit of an idea of what's likely to occur. The one thing that I discourage people from doing is trolling through them, finding the one that says what they want it to say and go with that. Better off having a look at a handful of them that you like and getting a consensus view. For those interested in how other farmers have used climate information, Climate Kelpie Ask a Farmer, Climate Champion program provides some really good examples of how people have used climate information in the past, whether or not it's worked, whether or not they like it, etc. like that. In terms of day-to-day management tools, as I said, the Queensland Government website now provides free Rainman stream flow, so you can go and download it and start using it yourself. Other things such as the How Wet program, which is a soil moisture program, Wiper Cropper, which looks crop outlooks using things such as SOI, soil moisture, etc. For beef producers, I would like to point out, and I don't know how many people use this, but the MLA have some really good management assistance tools, especially things such as their Rainfall to Pasture Growth Outlook tool, and there's a link to that one there. And to finish off with, if you're interested, and even though today I only covered a small handful of drivers that impact on our climate, there are a number of other drivers that do impact on our climate. For example, over the last 6 months, certainly the subtropical ridge of high pressure has been further north than normal, and that has a drying influence on expected rainfall across much of Queensland, northern New South Wales during winter. So if you're interested in those type of things, if you go to the Bureau's website there, provides quite a good explanation of what other things impact on our climate and weather. Thank you. There's my contact details there. I'm happy if anyone's interested in the list of or the links to the web pages that I have a look at. Flick us an email and I can email you back. I'm also happy to answer any questions. I haven't gotten through all the questions I received after the last webinar, but I promise I will get through them all before the end of the month. And does anyone have any questions?